So I'm hoping this is some review for us, but we're going to cover it anyway just so we got this down. But we're going to come up with our formula for slope. And remember, slope is like the steepness of a line. And it's represented by the change in the y, which is our output, over the change in our x, which is our input. And we've already done that. We found the rate of change, right? Slope is the same thing as our rate of change from previously. So that's the nice part. We should already have some experience in finding slope. So for our equation, our formula that we're going to write for slope, we got to remember that we need to represent slope somehow. So we're going to use the letter M to represent slope. And we have to remember that slope is always rise over run. Rise over run. Or the change in the y's over the change in the x's. Right? We use that triangle to represent change. It just means you subtract. Well, if I wanted to actually find this slope, I need to know 2 points on the line. So over here I have 2 points on this line. Okay? The one I just called point 1, right? x1, y1. And the other one I called point 2, x2, y2. So if I wanted to find the slope, I would find the change in the y's first. So I would subtract my y's. Well, which ones are my y's? y2 minus y1. So that's what I'm going to do on top. I take y2 minus y1. And then I put that over, well, the change in my x's. So I started with y2, so I better start with x2 and subtract x1. x2 minus x1, just like that. So here is a nice formula to use for slope. And we need to know that because we're going to derive our point slope form from that formula, which we'll find out in a few sections. Don't worry about that now. But in this case, you know, if I were to actually calculate this slope, if we take a look, this point right here is really 2, 4, right? It goes right 2 up 4. And this point right here is really right 7, and it goes up 7 as well. And if I'm given it on a graph, I would probably just count. I would start at one point and count. I'd count the rise. It goes up 1, 2, 3. It has a rise of 3 and a run of 1, 2, 3, 4, 5, and a run of right 5, so that's a positive 5, so 3/5. And if I actually wanted to use my formula, I would say that subtract my y's on top, so I would take 7 minus 4 up top, and since I started with this 7 to subtract 4, I got to start with this 7 to subtract 2 for my x's. 7 minus 2, I should get the same thing, 3/5 for the slope. There we go. So let's get some practice finding some slope. So finding the slope of the line that passes through the pair of points. So first of all, I'm going to graph these 2 points. So negative 3, 2, negative 3, 2, and 5, 5. So 2, 4, 5, 5. All right, now I'm going to draw in my line here. Pretty good, not too bad. Okay, so I could count the slope, but I might not be given a graph. But just by looking at my graph, do you think this is going to be a positive slope or a negative slope? Well, yeah, it's going up, so it should be a positive slope. Okay, so let's use my slope formula. Now, it doesn't matter which one you start with when you subtract your y's on top. I could take 2 minus 5 or 5 minus 2. It won't matter. If I take 5 minus 2, then how do I need to subtract my x's? Yep, I better take 5 minus negative 3. And that would give me 3 over, well, subtracting a negative is really adding a positive, 8, a slope of 3/8. If I did it the opposite way, let's say I would have taken 2 minus 5 first. If I'd have done 2 minus 5 on top, then I would just have to go negative 3 minus 5. Let's see if I get the same thing. I'd get negative 3 over negative 8, which is positive 3/8. So it works both ways, right? Let's take a look at another one. Negative 3, negative 4. And negative 2, negative 8. All right, so now my line, it looks something like this. Okay. Now what kind of slope do you think we're going to have, positive or negative? Well, now it's going down, so I should have a negative slope. All right, so to find the slope, subtract your y's on top because that's your rise, right? The rise is on top, the run is on bottom. So always remember, y's on top, x is on bottom. So y's on top, negative 8 minus negative 4. Just be careful with those negative signs. And x is on bottom, negative 2 minus negative 3. And then, remember, minusing a negative is really adding a positive. So negative 4 over, same thing here, positive 1. So really our slope is negative 4. just like that. If you leave it like -4/1, that's fine. It's nice to have a rise and a run, but we can always simplify. All right, how about something like this? Now let's be careful here. So I got -3, 4, so -3, 4. And then I have 4, 4, 4, 4. All right, ooh, what kind of line do we have here? This guy's a perfect horizontal line. And why is it horizontal? What's similar between my 2 points? Yeah, the y's are the same. The y's are the same. Okay, so this is a little bit tricky for our slope. Well, how do I find our slope again? All right, subtract our y's on top, subtract our x's on bottom, and I would get 0/7. Well, 0 divided by 7 is what? Just to be safe, I'm going to take my calculator because sometimes 0 can be tricky. So I like to just put this in my calculator just to make sure. So I'm going to go 0 divided by 7, and I get 0. Okay. So that equals a slope of 0. Well, if I think about this for division, 0 divided by 7. Can I take 0 and break it into 7 equal parts? 1, 2, 3, 4, 5, 6, 7. That add up to 0? Sure. I could add 0 7 times. These are all equal parts. So that's why it has a slope of 0. It works. And if I think about this, a horizontal line, I could walk on this line, right? So I think it has a slope. It's got a slope, but the slope is 0. And I'll tell you why I think about that when I get to my next example, which is right here. So now let's graph these 2 points, 3, -2, and 3, 4. So what kind of line do we have here? Vertical, 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 vertical. All right. Well, what's going to be the difference here? When I find my slope, let's subtract my y's on top. Let's subtract my x's on bottom. And we got 6/0. Is this also 0? Let's check. The easiest way to check is to grab your calculator and actually type in 6 divided by 0. 6 divided by 0. Whoa, I got an error. Divide by 0 error. It does not work. Why doesn't it work? Well, let's think, what does division mean? It's saying take 6 and break it into 0 equal parts that add up to 6. Can I break something into 0 equal parts? No. So this doesn't have a slope. There's no slope here. So what we call this, we say this slope is undefined. You need to know this. The slope is undefined. So m equals undefined. It's not defined. There is no slope. And so I think about this. I think about the person walking. Can a person walk on a vertical line? No, unless they're Spidey-Man, they're not walking on that vertical line. They'd be falling like this. Okay, so that's why there's no slope. It's undefined. And what do you notice about this? X's are the same. The X's are the same for a vertical line. Okay, and we're going to get into equations of line pretty soon here, quick too. So that's important that we know both those guys. All right, what if I get something like this? It says consider the line through the points 1, 7 and 6, 4. Find the coordinates of another point on the line. Well, let me just graph them first of all. So 1, 7 and 6, 4. 2, 4, 6, and 4. Okay, it's not good that I just draw on my line randomly. What should I do? What's important to know about this line if I want to find another point? Yeah, you need to know the slope. Okay, so how do I find the slope? Subtract my y's on top. So I'm going to go 4 minus 7. And subtract my x's on bottom. Since I started with 4, I got to start with 6. So 6 minus 1. And I get -3/5. So -3/5. So how could I find another point? Well, our slope has a rise and a run, just like this. Okay, well, I got a question here too. What happens if I bring my negative sign out front and write it as -3/5? So let's decide for my rise and my run what I would use. Okay, so if I wanted to find another point, so let's go to this point right here, my 1, 7. I could use that slope of -3/5, but I got to decide, where should I give this negative to? Well, it looks like I can give it to the top, right? If it's out front, can I give it to both? Can I say -3 and -5? So can I go down 3 because it's negative and then left 5? Would that work? No, a negative divided by a negative is really a positive, so this does not work. We can't do that. So when you have a negative sign out front, be careful with this. You have to either give it to the top or you have to give it to the bottom. So what that means is I can either go down 3 and right 5 from each point. So if I started at this point, I could go down 3, 1, 2, 3, right 5, 1, 2, 3, 4, 5. Good. I could go down 3, right 5, 1, 2, 3, 4, 5. So what point would that be? That would be 11, 1. Good. And I could go the other direction too. I could really go up 3 and left 5. So let's go back to my original point. Let's go up 3, 2, 3, and left 5. 1, 2, 3, 4, 5. Right there. And this point would be what? Negative 4 and 10. So that would be my line. So I came up with 2 points, negative 4 and 10, and 11 and 1. So really, what did I do? The one case, so if I look back at my points up here, the one case I used the slope negative 3, 5 over 5. In the other case, I used 3 over negative 5. And the one, what did I do? I took negative 3 and put it to the rise, right? So I subtracted 3 from there, and I added 5 to there to give myself 11, 1. Same thing with this other one. I did it to the other one, so I added 3 to the y because of rise, and I subtracted 5 from the run because of 4, and I got my point, negative 4, 10. Okay, so there's multiple ways to use your slope to find multiple points on your line. What if we actually wanted to write an equation of a line now? Well, what do we need to write something in? Well, when it says intercept form in your book, let's use y equals mx plus b. Let's use slope intercept form. So let's always use slope intercept form. I don't like that intercept. So you're always going to see it as like a plus bx, but let's use mx plus b. I like that better. Okay. Well, what do I need to know? I need to know the slope, then I need to know the y-intercept. So what is the slope here? What can I do? Well, if I have it on a graph, I can count. It's going right 1, 2, 3, and it's going down 1, 2, 3, 4, 5. So I should have a rise of negative 5 and a run of 3. Let's double check it. Let's use my coordinates here. So subtract your y's on top, 2 minus negative 3. Subtract your x's on bottom. I got to start the same way, so 0 minus 3. And I'd get 5 over negative 3. So negative 3 are 5/3. That works out perfect, right? There's my slope. Well, what's my y-intercept? We're going to come up with a way how to find the y-intercept pretty shortly. But if I look here, it crosses the y-axis at 2. Remember, because we're looking for when x is 0, right? When the input is 0, that is the y-intercept. So my y-intercept is 2 in this case. So I would say y equals negative 5/3 x plus 2. Done. Okay. So don't worry about solving for y-intercepts yet. Hopefully we should be able to see it for now. And then in a section or two, we're actually going to start solving for those y-intercepts.